In today's video, we will answer all the questions posed in Model Question Paper 1 released by the State PU Education Board. This is as per the latest reduced syllabus for the year 2021. There will be, the time given will be 3 hours 15 minutes and a maximum marks will be 100. And as per the instructions, the question paper has 5 parts, namely A, B, C, D and E. And you are required to answer all the parts. And you may use graph sheet for answering the question on linear programming, that is in part E. Let us start. Part A. Answer all the questions. There will be 10 questions of 1 mark each. So first question is define an empty relation. Definition given in the textbook. Therefore, answer is a relation R is a set. A relation R in a set A is called empty relation if no element of A is related to any element of A, that is R equals, that is relation R equals phi a subset of A cross A. Question number 2. Write the domain of the function y is equal to secant inverse x. Answer. The domain of secant inverse x is R minus within small bracket minus 1 comma 1 or within bracket minus infinity comma minus 1 union 1 comma infinity. Question number 3. If a matrix has 5 elements, what are the possible orders it can have? Solution. The possible solutions are 5 into 1 or 1 into 5, 1 cross 5, or it can also be written as within small brackets 5 comma 1 or within a small bracket 1 comma 5. Find the values of x for which matrix x2 18x equals 6 to 18 6. Therefore, so we have to solve it. Therefore, x into x is x square minus 2 into 18 is 36. That is x square minus 36 on the left hand side equals 6 into 6 36 minus 18 2 into 18. Therefore, simplifying we get, so this 36 gets cancelled, and if you take this minus 36 on the right hand side, we get x square is equal to 36 or x is equal to plus or minus 6, that is square root of 36, that is equal to plus or minus 6. Question number 5. If y is equal to tan root x, find dy by dx. Therefore, we have to differentiate. That means because we are required to find dy by dx, differential with respect to x is equal to differentiate y is equal to root x. That is, therefore, dy by dx is equal to, we know from the standard values, you have to remember secant squared root x into d by dx of, this is the inside item root x. Therefore, that is equal to secant squared root x into d by dx of root x is using power rule 1 divided by 2 into root x. Question number 6. Find integral within brackets 2x square plus e to the power of x dx. Therefore, taking integral, we get integral of 2x square plus e to the power of x dx is equal to integral integral of 2x square plus integral e to the power of x dx. That is, we have separated the function within brackets. That becomes 2 into, using power rule, x square, integral of x square is x cube by 3. So that is written x cube by 3 plus integral e to the power of x is e to the power of x itself plus constant of integration. Therefore, that becomes 2 into x cube by 3 plus e to the power of x plus c. Next part. That is continuing part A, the remaining questions. Question number 7. Define a negative vector. This is also as per your textbook. The definition. So, answer. A vector whose magnitude is same as the vector, say AB, but direction is opposite. So, for negative vector, magnitude is same but direction is opposite to that of it is called negative vector. That is, vector BA will be equal to minus of vector AB. Question number 8. If a line makes an angle 90 degrees, 135 degrees and 45 degrees with XYZ axis respectively, find its direction cosines. Solution. Direction cosines are cos alpha, cos beta and cos gamma. So, that is, we can direction cosines are cos of 90 degrees. Cos of 90 is 0. Cos 90 from our trigonometric knowledge, cos 90 is 0. Therefore, cos 135 is, that is equal to, we know, that is cos 90 plus 45. That is equal to minus of 1 by root 2. And cos 45 is 1 by root 2. And next question. Define the optimal solution in a linear programming problem. So again we have to define it. It is a definition given in the textbook. Any point in the feasible region that gives the optimal value, either maximum or minimum, of the objective function is called the optimal solution. Question number 10. If PA is equal to 7 by 3 and PB is equal to 9 by 3 and P of A intersection B is equal to 4 by 13, evaluate conditional probability of A upon B. Therefore, we have by formula, conditional probability of A upon B is equal to probability of A intersection B divided by probability of B. That is equal to 4 by 13. That is, PA intersection B is 4 by 13 and P of B is given as 9 by 13. So 13 gets cancelled. Answer is 4 by 9. So we have answered all the 10 questions and now we have scored 10 marks. So we will go for the next section, that is part B. Answer any 10 questions. So each mark is 2 marks question. There will be 10 questions of a total of 20 marks. Question number 1. Let star be a binary operation on Q defined by A star B is equal to AB by 2 for all values of A, B belonging to Q. Show that star is associative. That is, the binary operation is associative. Answer. Given binary operation star on Q as AB by 2. A star B is equal to AB by 2 for all values of A, B belonging to Q. Therefore, let A, B, C belonging to Q. Therefore, A star B star C, that is A star B within brackets, star C is equal to AB is given as, we know, AB by 2 in star C. That is equal to AB, we can write this as AB into C divided by 2. That is, this 2 and divide by 2 if we take it, divided by 2, that is equal to ABC by 2 into 2 is 4. Let it be equation 2. Therefore, applying again by 1, now we will interchange the bracket. So, A we will take outside. A star within brackets B star C is equal to A star BC by 2. So, again we will write A outside into BC by 2 divided by 2. So, simplifying, we get ABC divided by 4. Hence, binary operation of A star B star C is equal to A star within brackets B star C for all values of A, B belonging to Q. This is the answer. Question number 12. Find the principal value of cot inverse of 1 by root minus 1 by root 3. Therefore, let cot inverse of within brackets minus 1 over root 3 be equal to y. Then cot y is equal to, taking cosine for each both left side and right side, cot y is equal to minus 1 by root 3, or that is equal to, this one is equal to cot of pi by 3. We know from this value cot of 1 by root 3 is cot minus cot of pi by 3. Therefore, that becomes cot of, because to eliminate negative sign outside, we subtract from 180 degrees. That is cot of pi minus pi by 3. That is equal to cot of, simplifying, 3 pi minus pi is 2 pi by 3. Cot of 2 pi by 3. We know the range, from the range of principal values of cot inverse is, the range for cot inverse is 0 to pi, and therefore cot 2 pi by 3 equals minus 1 by root 3. Hence, principal value of cot inverse of within brackets minus 1 by root 3 is 2 by 3. Question number 13. Find the area of triangle whose vertices are 2, minus 3, 3, 2 and minus 1, minus 8 using determinants. So, we are required to find the area of the triangle, and given all the 3 vertices are given. So, let us solve it. Solution. Area of the triangle is given by area triangle equals half into, we have to write 1 1 1 in the third column, and the remaining vertices are to be written here, minus 2 3 minus 3 3 2 minus 1 minus 8. So rearrange the given vertices as shown in the screen. Therefore, that is simplifying, half into, take minus 2 into 2 into 1 is 2, minus of minus is plus, so 8, 2 plus 8, plus here it becomes, this is plus, this is minus, this is plus sign. So this outside minus sign into minus 3 becomes plus 3. Outside minus 3 and inside minus 3 plus 3 into, you cancel the second column and first row, you get 3 into 1 is 3, minus of minus is 1. Therefore, it becomes plus 1 plus this 1 plus 1 into minus 24. That is 3 into minus 8 is minus 24. Then minus of minus is plus into 2. So, now we will simplify. That is equal to half into 2 into 8 plus 2 is 10, minus 20, plus 3 into 4, 12, minus 22 into 1, that is equal to minus 30. Simplifying, that is minus 20 minus 22 is 42 plus minus 42 plus 12 is minus 30. That is equal to minus 15. That is the answer. You please, for all the detailed calculation, concepts, theory, refer our videos. These are all explained in detail. So here the area, the calculation, we have got minus 15. You should not write area as minus 15. You have to write area is equal to plus 15 square units. This is very important. Otherwise, your marks will be cut. Question number 14. Find dy by dx if y is equal to cos of log x plus e to the power of x comma x greater than 0. Therefore, you will get y is equal to solution. Y is equal to cos of the given function is written as it is. Log of x plus e to the power of x where x is greater than 0. Then we have to differentiate with respect to x. Therefore, dy by dx is equal to differential of cos x is minus sin x. So it is written as minus sin of within bracket. The term within bracket is written as it is, that is log x plus ex into differential of the term inside the bracket. Therefore, it is d by dx of log x plus e to the power of x. Therefore, that is equal to minus sin log x plus e to the power of x into d by dx of log x is 1 by x plus d by dx of e to the power of x is e to the power of x itself. So simplifying, we get minus sign you take outside. That is equal to sine of log of e to the power of x by x plus e to the power of x into sine of log x plus e to the power of x. Next question. Find dy by dx if sine squared x plus cos squared y is equal to 0. Please note here, it is sine squared x plus cos squared y equals 1. The function, the equation in the question. Therefore, we will copy the given function, that is sine squared x plus cos squared y is equal to 1. That is equal to, we will differentiate with respect to x. So differential of sine squared x is 2 into sine x into d by dx of sine x. Okay, plus 2 into cos y into d by dx of cos y equal to d by dx of 1 is 0. D by dx of constant is 0. Therefore, that becomes 2 into sin x, d by dx of sin x is cos x, plus 2 cos y into d by dx of cos y is minus sin y into dy by dx. That is the dy by dx of the inside, the function inside here. You please note this step here very carefully. Lastly, it is appearing dy by dx equal to 0. Therefore, retaining dy by dx on one side and taking the other terms on the right side, you take this 2x sin x, 2 sin x cos x on the right hand side, 2 sin x cos x divided by this term, 2 cos y into minus sin y. That is equal to minus 2 cos y sin y. This minus 2 on the numerator and minus 2 in the denominator gets cancelled. Therefore, the function becomes sin x cos x divided by cos y sin y. Next question. If y is equal to x cube plus tan x, then find d squared y by dx squared, because we have to find the second order derivative, second derivative. Okay, first we have to take first derivative and then next second derivative. Given equation is noted down as it is. Y is equal to x cube plus tan x. Therefore, if we differentiate, dy by dx is equal to 3x squared plus d by dx of tan x is secant squared x. You have to recall and remember it. Please go back to differential equation, differentiation. Therefore, again we have to take the second differentiation. So differentiate again with respect to x. So dy by dx becomes, in the second order derivative, second derivative, d squared x by dy squared is equal to 3 into 2x plus 2 into secant squared x tan x. That is, differential of secant x is secant x tan x. This also you have to remember. Okay, differential of tan x also you have to remember, and differential of secant squared also you have to remember. So that becomes 6x, 3 into 2x is 6x plus 2 into secant squared x tan x. That is the answer. Next question, find the slope of tangent to the curve. The given equation is y is equal to x cube minus x at x is equal to 2. Therefore, now we will solve it. Note down the given equation. The given equation is x cube minus x. The dy by dx. Now we will differentiate this equation. We will take dy by dx. That becomes differential of x cube is 3x squared minus dy by dx of x is minus 1. Therefore, now the given point is at x is equal to 2, we are required to find the tangent. So, substitute x is equal to 2 in the differential equation. Therefore, at x is equal to 2, dy by dx, which is the tangent, equals 3 into 2 square minus 1. That is equal to 11. That is the answer. Next question. Question number 8. Find 0 to pi within brackets, big brackets, sine squared x by 2 minus cos squared x by 2, close the bracket, into dx. Please note down the equation. Copy it as it is. So it is written as on the left hand side term. On the right hand side, we will substitute the value of sine squared x by 2. By formula we know sine squared x by 2 is 1 minus cos x by 2 minus 1 plus cos x by 2. That is, we are using the formula for cos squared x by 2, half angle into full angles. That is, sin squared theta is equal to 1 minus cos 2 theta by 2, and cos squared theta equals 1 plus cos 2 theta by 2. This formula we know from the trigonometric functions. You have to remember, and you please note down all these things and practice. Therefore, this equation, that is integral 0 to pi 1 minus, so we will add it, subtract that 1 minus of 1. If you add both these equations, the first term after the integral side and the second term, if you add 1 minus cos x minus 1 minus cos x. So it is written here divided by 2. 2 is common for both the terms, divided by 2. That is equal to 1 and 1 get cancelled. It becomes minus 2 cos x divided by 2. So the 2 gets cancelled. We get integral of cos x dx equals minus sin x, that is value of 0 to pi, minus sin pi, that is upper limit, minus sin 0 is lower limit. Therefore, sin 0 is 0, sin 80 is also 0. The whole value is 0. That is the answer. Question number 19. Find integral of x secant squared dx. That is equal to solving, we get x secant integral, given integral becomes x secant squared dx, x into integral secant squared x dx minus integral of d by dx of x into integral secant squared x dx. This is the standard integral formula. That is equal to x tan x minus integral 1 into this is the integral 1 into integral of secant squared x is x tan x dx. That is equal to x tan x, this equation x tan x minus integral of 1 tan x dx is minus log of mod x plus c. That is equal to x tan x plus log of mod x plus c. That is the answer. You have to remember this. Find the order and degree of differential equations y triple dash plus 2y dash is plus y dash equal to 0. We have to find the order. Here you know the highest derivative is 3 here. Y triple dash. Okay. Y triple dash. So the highest order is 3 here and its power is 1. So the highest order derivative is y of 3 dash is 3. So its order is 3 and its degree is 1. Find the projection of vector A equals I plus 3j plus 7k on vector B 7i minus j plus 8k. So given A is equal to I plus 3j plus 7k and B is equal to 7i minus j plus 8k. Therefore, projection of A on B is given by the dot product of A dot B divided by mod of vector B, because projection of A on B. Therefore, that is equal to A dot B is A is 1 into 7 plus 3 into minus 1 plus 7 into 8. That is the respective coefficient of unit vectors I, j and k divided by a square plus b square plus c square. That is divide mod of b is 7, a square is 7 square plus 1 square plus 8 square. That is the coefficient of vectors b's unit vectors, coefficient of unit vectors of b. Simplifying, we get that answer as 60 by 114. That is equal to, you can divide it, that is 30 divided by 57. This answer you can write. So question number 22. Find the area of parallelogram whose adjacent sides are determined by the vectors A is equal to I minus j plus 3k on vector B is equal to 2i minus 7j plus k. Therefore, given vector is A is equal to I minus j plus 3k and B is 2i minus 7j plus 3k. Please see the diagram here. A is one side of the parallelogram given by the relationship vector A is equal to unit vector I minus unit vector j plus 3 times unit vector k, and side B is 2i minus 7j plus 7k. So we have to find the area, we have to multiply it. That is, we have to find the cross product. So for finding the cross product, you write a matrix I, j, k as unit vectors, then coefficient of A1, A2, A3, that is vector A's coefficient, and vector B in the third row as shown in the figure, as shown in the screen. So the A cross B is equal to I jk into 1, coefficient of I is 1, and coefficient of j is -1, and coefficient of k is 3. And in the third row, we will write the coefficient of vector B. That is, coefficient of I is 2, and coefficient of j is -7, and coefficient of k is 1. So now we have to find A cross vector B. Therefore, A cross B is equal to I into -1 into +1 is -1. Minus of -7 is +7 into 3 is 21. Minus again minus j into, cancel this second column and first row, you get 1 into 1 is 1, minus 2 into 3 is -6, plus k into 1 into -7 is -7, minus into minus 2 plus 2. That is equal to, simplifying, I into -1 plus 21 is 20. Minus here becomes within bracket -5. -5 into minus is +5j, and -7 plus 2 is -5. That is -5k. That is the answer. Area of the parallelogram is mod of A cross B. Therefore, we have to take the modulus of the above function. That is equal to 20 whole square root of, area is equal to square root of 20 square plus 5 square plus within brackets square of -5 square. That is equal to 400 plus 25 plus 25. That is equal to 450. That is equal to 15 root 2 square units. Find the equation of plane with intercepts 2, 3 and 4 on x, y and z axis respectively. Therefore, let small a be equal to 2, small b is equal to 3 and small c is equal to 4. Then we know from the formula, the equation is x by a plus y by b plus z by c is equal to 1. That becomes x by 2 plus y by 3 plus z by 4 equals to 1. Therefore, taking LCM, we get 6x plus 4y plus 3z divided by 12 equals 1, or 6x plus 4y plus 3z is equal to 12. That is the answer. That is the equation. Question number 24. Assume that this is on probability. Assume that each child born in a family is equally likely to be a boy or girl. If a family has 2 children, what is the condition probability that both are girls, given that the youngest is a girl? Let us solve it. Here you see there are 2 children. The first can be boy and the second can be girl. So let the first child be denoted by capital B or capital G. If it is a boy, it is first child is capital. So capital B or capital G. The first child can be a boy or a girl. And the second child can be a boy, small b, or a small g. So second child is denoted as small b or small g. We have denoted it. Therefore, the sample space possibilities is the sample space S is given by within brackets. The first can be a boy and second one can also be boy. So it is written as boy boy. And the second possibility, second outcome could be the first can be a boy and the second one can be a girl. So it is written as capital B and a small g. And the third possibility is the first child can be a girl. So it is written as capital G, and second child can be a boy. So it is written as small b. And the last and final possibility is first can be a girl. So it is written as capital G, and second can also be a girl, small g. So the total number of possibilities, that is the sample space n of S is equal to 4. Therefore, let E is equal to, that is, both are girls. You see here, it has a conditional probability that both are girls. So E is capital G and small g. That is equal to number of times E can happen is 1 only. That is, out of this 4, only this can. This is only 1. 1 out of 4. So probability of event E that both can be girls is 1 in 4. Therefore, now let us take the F, the second event, that the second child is a girl. See, given the youngest is a girl means the second child is a girl. So F is equal to, the second child is a girl, that is equal to capital B G. That is, this is the possibility. Second girl is here, second girl is here. So capital B, small g, capital G and small g. That is equal to probability of F is equal to 2. 2 here, and total sample space is 4. So it is 2 by 4. Therefore, E intersection F, here you see E and F, the common point is capital G, small g. So number of times of E intersection F is equal to 1. So 1 here. So therefore, probability is E intersection F is 1 in 4. Therefore, we can write conditional probability of E that already F has occurred. That is, E upon F equals E intersection F divided by probability of F. That is equal to P of E intersection F is 1 by 4 divided by probability of F is equal to 2 by 4. That it becomes 1 over 2. So the probability, the answer is 1 upon 2. Now we will take up 3 marks questions. There will be 10 questions. You have to answer all the 10 questions of part C. Let us start. This question number 25 is from chapter number 1. So the question reads as, show that the relation R defined in the set A of triangles as R within flower brackets and small bracket T1 comma T2 such that T1 is similar to T2 is equivalence relation. We have to prove that. This example we have also worked on in our regular video. Please go through it. The links are given in the description part of the video. So answer, solution. R is reflexive since every triangle is congruent. There further, T1 comma T2 belongs to R. Therefore, T1 is congruent to T2 and T2 is congruent to T1 because they are belonging to themselves. So, T2 comma T1 belong to R. Hence, R is symmetric. Moreover, triangle T1 comma T2 comma T2 comma T3 belong to R. Therefore, T1 is congruent to T2 and T2 is congruent to T3. Therefore, T1 is congruent to T3. Therefore, that is T1 comma T3 belong to R. Therefore, R is an equivalence relation. Question number 26. For matrix A, 1, 5, 6, 7, verify that part 1. A plus A dash is a symmetric matrix. And part 2 is A minus A dash is a screw matrix. A dash is the transpose of matrix A. So answer given A is equal to 1, 5, 6 and 7. Therefore, we will find A dash. That is, we will change rows by column and column by rows. Therefore, A dash is 1, 6. That is, column 1 becomes row 1. 1, 6. And column 2 becomes row 2. So, 5, 7. So, A dash is 1, 6, 5, 7. Therefore, A plus A dash, adding these two, we get 1 plus 1 is 2, 5 plus 6 is 11, 6 plus 5 is 11, and 7 plus 7 is 14. Hence, now A plus A dash of dash equals, now we will transpose this. We will find the transpose of A plus A dash. So, 2, 11, that is first row becomes first column, 2, 11 and 11, 14. So, A plus A dash of dash is that. Hence, A plus A dash is a symmetric matrix. Next part. Let B is equal to A minus A dash. That is equal to 0. Now we will find A minus A dash. 1 minus 1 is 0. 5 minus 6 is minus 1. 6 minus 5 is 1. 7 minus 7 is 0. Therefore, B dash is equal to, now B dash is, we will transpose this. Therefore, 0, first row is 0 and first column is 0 minus 1 and second row becomes second column. Therefore, it is 1, 0. Therefore, taking minus 1 common from right hand side of B dash, we get B dash is equal to minus of 0 minus 1, 1 comma 0. Therefore, it is equal to minus B. Hence, it is a skew matrix. So, matrix B is a skew matrix because B dash is equal to minus B. Next question. If x is equal to 2at square and y is equal to at to the power of 4, then find dy by dx. This is a very simple problem. You can do it yourself. Therefore, we will do quickly. X is equal to 2at square and given y is equal to at to the power of 4. Dx by dt. Now we have to differentiate with respect to t here. There is no y term here. So, it is dx by dt is equal to 2a into 2t. That is equal to 4at. Similarly, dy by dt is equal to a into 4t cube. That is equal to 4at cube. So, let it be equation 2. Therefore, we have to require to find dy by dx. So you divide equation 2 by 1. If you divide it, that is 480 cube divided by 480 is equal to t square. That is the answer. Dy by dx is equal to t square. That is the answer. Question number 28. So find dy by dx. If x to the power of y is equal to y to the power of x, given x to the power of y is equal to y to the power of x, therefore take log of both sides. So y log x is equal to x log y. Let it be equation 1. Differentiating with respect to x, we get y into differential of log x is 1 by x, plus that is u into y, product of two, say u into y. So that is u into v dash plus v into u dash. So using that we get y into 1 by x plus log x into dy by dx is equal to, similarly on the right hand side, x into dy by dx is d by dx of log x is 1 by y into dy by dx plus log y into dx of dx is 1. So which is not written here. Therefore, this becomes dy by dx, segregating dy by dx on one side, we get dy by dx, if we take common, log x minus x by y, this term equals log y, that is on the right hand side, log y minus of y by x, rearranging. So therefore, dy by dx is equal to log y minus y by x divided by log x minus x by y. So simplifying, we get dy by dx is equal to y into x log y minus y divided by x of y into log x minus x. Next problem. Find the intervals in which the function f given by fx is equal to x square minus 4x plus 6 is a strictly increasing and strictly decreasing. Therefore, we have a given function is fx is equal to x square minus 4x plus 6. Therefore, differentiating first derivative f dash is 2x minus 4. d by dx of 6 is 0. So, only we get 2x minus 4. Therefore, f dash x is equal to 0 gives, if you put f dash is equal to 0, if you put x is equal to 2 here, we get f dash x is equal to 0. This point divides the real line into two disjoint. Therefore, the variable is minus infinity to 2. That is, 2 is the division. So, minus infinity to 2 is 1 point. And next is 2 comma infinity. In the interval minus infinity to 2, f dash x is equal to 2x minus 4 less than or equal to 0. Hence, it is the, and therefore f is decreasing in the interval. So f is decreasing between minus infinity to 2, and also in the interval 2 to infinity, f dash x is greater than 0. So the function f is increasing. So it is decreasing between minus infinity to 2 and increasing in the interval 2 to infinity. Next question. Evaluate sin cube x plus cos cube x divided by sin squared x into cos squared x. Into dx. Now to solve this, we have to separate sin cube x and cos cube x and integrate separately. Let us do it. Given function is written as it is. Therefore, the first function is sin cube x divided by the denominator into dx plus cos cube x divided by the same denominator, integral of into dx. Therefore, sin squared x gets cancelled with cube and remains sin x, and cos squared x is as it is into dx plus cos squared x in the denominator gets cancelled with cos squared x in the numerator and only cos x remains, cos x by sin squared x dx. Therefore, it is integral of sin x by cos x is tan x. 1 sin x and 1 cos x is tan x. 1 cos x remains, so that 1 over cos x is secant x. Plus cos x by sin x, 1 sin x in the denominator is cot x, and 1 sin x remains in the denominator, which becomes 1 over sin x is cosecant x dx. So integrating, we get tan x cx is integral of tan x secant x is secant x itself minus integral of cot x cosecant x is minus cosecant x plus c. This you have to remember, the standard integral of tan x secant x and cot x cosecant x. Then you will get this answer, secant x minus cosecant x plus c. Next question. Find integral x minus 3 into e to the power of x divided by x minus 1 whole cube into dx. You note down the given function as it is. That can be simplified as x minus 3 can be written as x minus 1 minus 2. This is minus 3 is minus 1 minus 2 divided by the denominator as it is into e to the power of x. This e to the power of x is written e to the power of x dx. Therefore, this becomes integral of e to the power of x into 1 divided by x minus this x minus 1 divided by x minus 1 whole cube. 1 x minus 1 gets cancelled and the remaining is 1 over x minus 1 square plus of minus 2 divided by x minus 1 whole cube. So this is only we have separated x minus 1 over one side and minus 2 another second term, separated as a different terms. That becomes, it is of the form integral e to the power of x fx into f dash x dx. This is of the standard form. This also you please go through our integration chapter number 7 on integrals, and these have been given details. The links are also given in the description part of this video. So this you go through in detail. Therefore, fx is equal to 1 by x minus 1 whole square. Therefore, that becomes f dash x is equal to d by dx of x minus 1 whole square. That is equal to minus 2 over x minus 1. Therefore, I is equal to e to the power of fx plus c. That is equal to e to the power of x divided by x minus 1 whole square plus c. That is the answer. Next question, 32. Evaluate integral dx of x plus 1 divided by x plus 2. Therefore, the integrand is proper rational function. Therefore, we can separate it as 1 by 1 over x plus 1 into x plus 2. That is the integrand can be written as a over x plus 1 plus b over x plus 2. Therefore, that becomes cross multiplying. We get a into x plus 2 plus b into x plus 1 is equal to 1. Therefore, coefficient of x, if you compare, coefficient of x is a plus b is equal to 0. Here in the left side there is no x term. Therefore, coefficient of x is 0 on the left hand side, and on the right hand side we have a plus b. So that is why we have rearranged it, a plus b equals 0. Therefore, again taking 2a constants, 2a plus b is equal to 1, because constant on the left hand side is 1. On the right hand side there are two constants, 2a plus b. Therefore, we get b is equal to a is equal to 1. Here if you see here, a is equal to minus b, or solving these two equations, if you put it, a is equal to 1 and b is equal to minus 1. Therefore, integrand is given by 1 over, that is 1 over x plus 1 into x plus 2 equals 1 over x plus 1 minus of, because b is minus 1, minus 1 divided by x plus 2. And this again, now we will take integration. Therefore, integral of 1 over x plus 1 into x plus 2 is equal to left hand side integral of dx by x plus 1 minus of dx by x plus 2. This can be written as log of integration is log of x plus 1 minus log of x plus 2 plus c. Therefore, it becomes, again simplifying, that is log of x minus log of x plus 2 can x plus 1 can be written as log of x plus 1 divided by x plus 2 plus c. That is the answer. Next question. Find the area of the region bounded by x square is equal to 4y, y is equal to 2 and y is equal to 4, the x-axis in the first quadrant. The first quadrant. Find the area of the region bounded by x square is equal to 4y is a inverted parabola upwards. Parabola inverted upwards. That is x square is equal to 4y. And there are two equations of line. Y is equal to 2 and y is equal to 4. Y is equal to 2 is a horizontal line parallel to x-axis, and y is equal to 4 is a horizontal line parallel to x-axis once again. So y is equal to 2, y is equal to 4. So now we are required to find the area of the first quadrant of this equation bounded by these two lines, that is the shaded region. This is also a worked example in the chapter. Therefore, equation of the curve upward parabola is given by, we have written x square is equal to 4x, or x is equal to root of 4x, that is equal to 2 root y. Therefore, the required shaded area is mod of integral 2 to 4 x dy, that is equal to integral 2 to 4 2 root y, that is we are substituting x as 2 root y. X is equal to, you see, 2 root y here in the given equation, 2 root y. Therefore, it becomes 2 take outside 2 to the power 2 to for limit y to the power of dy, that is equal to 2 into y to the power of 3 by 2, that is power rule half plus 1 divided by half plus 1. Therefore, it becomes y to the power of 3 by 2 divided by 3 by 2. Upper limit is 4 and lower limit is 2. Therefore, it becomes 4 by 3. In this here, it becomes inverted 2 into 2, 4 divided by 3. Upper limit is 4 to the power of 3 by 2 minus 2 into, lower limit is 2 into 2 to the power of 3 by 2. But we know 4 to the power of x to the power of 3 by 2 is given by x into root x. Therefore, 4 to the power of 3 by 2 will be written as 4 into square root of 4 minus 2 of 2 square root minus 2 times square root 2, square root of 2. Therefore, simplifying, it becomes 32 minus 8 root 2 divided by 3 square unit. This is also a worked example. Solve dy by dx is equal to e to the power of x plus y. Therefore, given dy by dx is equal to e to the power of x plus y. We will separate it and we will write it as e to the power of x into e to the power of y from the knowledge of our exponential function. Therefore, dy by e to the power of y is equal to e to the power of x into dx. Therefore, it is integral dy e to the power of y goes to the numerator and becomes e to the power of minus y. when it goes to the numerator equals integral e to the power of x dx. Therefore, minus of integral of this one, integral of e to the power of y is e to the power of y, but integral of minus y is minus 1. That is equal to e to the power of minus of e to the power of minus y equal to e to the power of x plus constant of integration c. Therefore, that can be written as c, retain it, and x you take here e to the power of x plus e to the power of y, retaining, and c goes left side, it should be minus c, and this can be another constant of integration. Next question. Question number 35. Let vector A, vector B, and vector C be three vectors such that mod of vector A is equal to 3, mod of vector B is equal to 4, mod of vector C is equal to 5, and each one of them being perpendicular to sum of the two. That means vector A is perpendicular to sum of the two, means vector B plus vector C. Similarly, vector B is perpendicular to sum of vector A plus vector C. And vector C is also perpendicular to sum of vector A plus vector B. That means each one of them, please read once again, each one of them being perpendicular to sum of the other two. In such circumstances, find mod of vector A plus vector B plus vector C. Let us solve it. Given vector A into, that is perpendicular means dot product 90 degrees. Therefore, A vector A dot B plus C is equal to 0 plus vector B dot vector A plus C is equal to 0, comma vector C dot vector B plus A is equal to 0. This you have to remember. That is the dot product of two vectors perpendicular, when the angle is 90 degrees, it is 0. So let us copy, let us note down vector A plus B and plus A multiply again with the same vector. Therefore, within brackets, vector A plus vector B plus vector C into vector A plus vector B plus C. We will find out what will happen. We will multiply A with A and B plus C first. Then we will multiply vector B with vector A plus C. Then vector C with C itself first, and then vector C into A plus B. Let us do it. Therefore, A into A plus A into B plus C plus B dot B plus B dot A plus C. Here you have to put the arrow mark here. Okay, plus C into C into plus C into B plus C. Substituting A square plus B square plus C square, that is A square plus B square mod of B square plus C square plus A dot B plus C is equal to 0. You see here in the first line given as A dot B plus C is 0, B dot A plus C is 0, and C dot B plus A is 0. Therefore, we have put 0 plus 0 plus 0, only remaining A square plus B square and C square. Therefore, the left hand side is A plus B plus C. Vector A plus vector B plus vector C whole square is equal to vector A square is given as 3. Here you see it is 3. 3 square plus vector B square is 4 square plus vector C square is 5 square. So 3 square is 9 plus 16, 25 plus 5 square is 25. Total is 50. So therefore, taking square root, on the left hand side we get mod of vector A plus vector B plus vector C is equal to square root of 50, that is equal to 25 into 2. Square root of 25 is 5 into square root of 2. That is the answer. Next question. Show that the points A of minus 2i plus 3j plus 5k, comma, point B I plus 2j plus 3k, comma, C of 7i minus vector k, unit vector k, are collinear. Okay, this we have to find out. Now we have to find out the sides and then we have to prove it. This is also a word example. You can follow it. Given OA is equal to, here you see minus 2, comma 3 minus 5. A. OB is, that is position vectors 1, comma 2, comma 3. And position vector C is 7, comma 0, comma minus 1. These are written as vectors here. Therefore, AB is OB minus OA. That is equal to 1 minus of minus 2 is plus 2, comma 2 minus 3, comma 3 minus 5. That is equal to 3, comma minus 1 minus 2. Therefore, BC is equal to OC, vector OC, position vector OC minus OB. OC is 7 minus 1, 0, 0 minus 2, minus 1 minus 3. That becomes within bracket 6, comma minus 2 minus 4. So we have found AB, vector AB as well as BC. Now we will find out vector AC. AC is given by the position vector OC minus OA. That is equal to OC is 7, minus of minus 2 is plus 2, comma 0 minus 3, comma minus 1 minus 5. So its coordinates are 9 minus 3 minus 6. Therefore, mod of A we will find out. Mod of A is given by 3 square plus minus of 1 square plus minus of 2 whole square under root. Simplifying, we get square root of 14. So, mod of AB is square root of 14. Next step is to find mod of BC. Therefore, it is given by mod of BC is equal to 6 square plus minus 2 whole square plus minus 4 whole square. Simplifying, that becomes 2 into square root of 14. Now in the last step, we will find out mod of AC. Mod of AC is given by 9 square plus minus of 3 square plus minus of 6 whole square. Simplifying, that becomes 3 into square root of 14. Now we will compare, we will see that AC is equal to AB plus BC. That is 3 square root 14 is equal to 2 square root 14 plus square root of 14. Hence, collinear condition is satisfied and points A, B and C are collinear. Question number 37. Find the equation of the plane through the intersection of planes 3x minus y plus 2z minus 4 equals 0, x plus y plus z minus 2 equals 0, and the point 2, 2, 2, 2, 2, 1. So the equation of plane of intersection of, there are two planes which are intersecting. That is, their equation is given and the point is also given. We have to find the equation of the plane given. So it is given 3x minus y plus 2z minus 4 is equal to 0, x plus y plus z minus 2 equal to 0. We have copied it as it is from the question. Therefore, equation of the given plane through intersection is given by, if this is a vector a plus lambda b is equal to 0. Therefore, we will write 3x minus y plus 2z minus 4 plus lambda, you see lambda into x plus y plus z minus 2 equal to 0. It is a very simple, only you have to substitute. Therefore, now the points we have to put x is equal to 2. It is given x is equal to 2, y is equal to 2 and z is equal to 1. We will put these values in the equation number 1. Therefore, it becomes 3 into 2 minus 2 plus 2, that is minus 2 plus 2 into 1 minus lambda. This is minus 4 also, we have written as it is minus 4 plus lambda into x is 2, y is 2 and z is 1 minus 2 equals 0. That becomes, simplifying, 2 gets cancelled. It is 2 into 3 is 6. 6 minus 4 is 2. When 2 goes to the right hand side, the sign changes. That becomes minus 2. And this term, that is multiplier of lambda, is 2 gets cancelled. 2 plus 1 is 3. Therefore, lambda is equal to minus 2 by 3. Now we have found the value of lambda as minus 2 by 3 and we have to put this value in equation number 1. Let us put it. Therefore, 3x minus 5 plus 2z minus 4 minus of lambda. This lambda we are substituting as minus of 2 by 3. So it is written here minus of 2 by 3 into x plus y plus z minus 2. So we have written it as it is equal to 0. Therefore, simplifying, we get 9x, see, taking LCM as 3, 9x minus 3y plus 6z minus 4, minus 12, sorry, minus 3, 3 into 4 is minus 12, minus 2x, minus 2y, minus 2z, minus into minus is plus 4 equal to 0. Simplifying, we get 7x minus 5y plus 4z minus 8 equal to 0. That is the answer. That is the equation of the plane. Next question. This is on probability. So let us solve it. It is a simple problem. Let us solve. A man is known to speak truth 3 out of 4 times. That means for every 4 talks, whenever he speaks 4 times, 3 times he tells the truth, and 4th time he says the false. So he throws a die and reports that it is a 6. Find the probability it is actually a 6. So every time he throws a die, he tells that it is a 6. So how many times he actually 6 and actually it is 6? We have to find out probability. Let E be the event that the man reports 6 occurs in throwing the die, and let S1 be the event that 6 occurs and S2 be the event that 6 does not occur. So S1 is the event when actual 6 occurs and S2 is the event that 6 does not occur. Therefore, probability of S1 is equal to probability that 6 occurs. That means 6 can occur only 1 out of 6 times. The probability of 6 occurring is 1 by 6. Therefore, probability that 6 will not occur is 5 times, 5 by 6. So during this 5 times it can be 1, 2, 3, 4, 5, but not 6. Therefore, probability of S2 is 5 by 6. Therefore, conditional probability that E has occurred, conditional probability of E upon S1 is 3 by 4. That is 3 out of 4. It is given. Therefore, conditional probability of E that S2 has occurred, that is 6 has not occurred, is 1 minus 3 by 4. That is equal to 1 by 4. Thus, by Bayes' theorem, we get conditional probability of S1 that E has occurred, that is probability that the report of the man that 6 has occurred is actually a 6 is probability of S1 into conditional probability of E upon S1 divided by probability of S1 into conditional probability of E upon S1 plus P of S2 into conditional probability of E upon S2. Therefore, subputting the values, that is 1 by 6 into 3 by 4 divided by 1 by 6 into 3 by 4 plus 5 by 6 into 1 by 4. So simplifying, we get it is 1 by 8, numerator is 1 by 8 and denominator is, it is 1 by 8 into 24 by 8. That becomes 3 by 8. Hence the required probability is 3 by 8. You please simplify this. Okay. You will get the answer as 3 by 8. Hence probability is 3 by 8. Next question. Now we will move to 5 marks question where you have to answer 6 questions. So it is on matrices. If A is equal to 1, 2, minus 3, 5, 0, 2, and 1, minus 1, 1, and B is equal to 3, minus 1, 2, 4, 2, 5, and 2, 0, and 3, and C is 4, 1, 2, 0, 3, 2, and 1, minus 2, 3. Verify that A plus B minus C is equal to A plus B minus C. So, matrix A, B and C has been given. We are required to prove that A plus within brackets B minus C is equal to A plus B within brackets minus of C. So first you will find A plus B and B minus C, and we will take sum or subtraction, addition or subtraction of matrix accordingly. So A plus B. A plus B is we have to add the corresponding coefficient, that is 1 plus 3, 2 minus 1, minus 3 plus 2. Similarly 5 plus 4, 0 plus 2, 2 plus 5. 1 plus 2, minus 1 plus 0, 1 and 3. That is A plus B. We have added A plus B and the results are shown here. And it is simplified as 4, 1 minus 1, 9, 2, 7, 3 minus 1 and 4. Now we will find this term, that is B minus C. B is given here. So from this matrix we will subtract C. Therefore B minus C will be 3 minus 4, minus 1 minus 1, minus 1 minus 1, 2 minus 2. So that is written in the first row. In the second row we get 4 minus 0, 2 minus 3, 5 minus 2. And in the third row we get 2 minus 1, 0 minus of minus 2 is plus 2, and 3 minus 3. So that gets simplified as matrix minus 1 minus 2 0, 4 minus 1 3, 1 2 and 0. Let it be equation 2. Therefore left hand side, now we will add This we will from B, we will add A to matrix subtraction of B minus C. That is, we will add A to equation 2. Therefore, if we add it here, A is 1, 1 minus 1, 2 minus 2, minus 3 minus 0 plus 0, and 5 minus 5 plus 4, 0 plus minus 1, and 2 minus 3, 2 plus 3. And the third row is 1 plus 1, minus 1 plus 2, and 1 plus 0. Therefore, it becomes 0, 0, simplifying 0, 0 minus 3, 9 minus 1 plus 5, 2, 1, and 1. Therefore, right hand side, now we will simplify the right hand side. A plus B we know already from equation 1. To this, from this we will subtract the C vector. This is the C vector. Therefore, from 1 we will subtract C from matrix C1. Therefore, it is 4 minus 4, 1 minus 1, minus 1 minus 2, 9 minus 0, 2 minus 3, and 7 minus 2. And next last row is 3 minus 1, minus 1 minus of 2 is plus 2. That is minus 1 minus of minus 2, 4 minus 3. These are all simple addition, and we will get, simplifying, we get right hand side as 0, 0, 3, 9 minus 1, 5, 2, 1, 1. Let it be equation 1. If you compare equation 3 and 4, we get left hand side is equal to right hand side. So again, solve the system of equation by matrix. So equations are given as 2x plus 3y plus 3z is equal to 5, x minus 2y plus z equals minus 4, and 3x minus y minus 2z is equal to 3. So these three equations are given, and we have to find the value of x, y, and z. Therefore, it can be written as in the form of equation 2, 3, 3, 1 minus 2 plus 1, 3 minus 1 and minus 2 into x into y into z. On the right hand side, we get b, that is 5 minus 4 and 3. That is ax plus b. Therefore, mod of a is equal to 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. Therefore, simplifying, we get 2 into minus 2 into 2, no, minus 2 is 4, minus into minus is plus, plus 1. Minus of this is minus, minus 3 into, so you cancel this, 1 into minus 2, minus of 3 into minus 1, minus 3, plus 3 into 1 into minus 1 is minus 1, minus of minus is plus, 2 into 3 is 6. That becomes, that is equal to 40. That is not equal to 0. Hence, we can apply. Solution is unique, and x is given by x is equal to ax inverse of matrix x. Therefore, b is equal to, that is equal to, x is equal to adjoint a divided by mod a into b. Let it be equation 1. Therefore, we have to calculate the cofactors of all by using the simple method as explained below. This is also a worked example. So you please calculate all the cofactors of the matrix A, and that becomes, we have calculated 5, 5, 5, and 3 minus 13 11, 9 1 minus 7. Adjoint means we have to transpose that. That means we have to find the transpose of matrix A. That is equal to 5. That is row is in replace, row is converted into column. Therefore, row is 5 5 5. It becomes adjoint A 5 5 5, and second row becomes 3 minus 13 11 as second column, 3 minus 13 11, and the third row, that is 9 1 minus 7, becomes third column, 9 1 and minus 7. Now we have found adjoint of A. Therefore, x is given by 1 over mod A into adjoint of A into B. Therefore, that is equal to 1 of mod A is 40. We have found here 1 by 40 into this adjoint A 539. This matrix is written 539, 5 minus 13 1, and 5 11 minus 7. That is equal to 5 minus B is 5 minus 4 3. That is B from this equation. Therefore, simplifying, we get x, y, z as 1, 2, minus 1. So, x is 1, y is 2, and z is minus 1. That is the answer. X is 1, y is equal to 2, and z is equal to minus 1. Question number 42. 42 is a very simple question. If y is equal to tan inverse of x whole square, show that 1 plus x whole square y2, that is the second derivative, y2 means second derivative, plus 2x into 1 plus x square y1 equals 2. Let's solve it. Given equation is written as it is, we differentiate. Therefore, we will find dy by dx is equal to 2 times tan inverse of x into integral of differential of inside x 1 over x square. Differential of tan x is 1 over 1 plus x square. Therefore, cross multiplying, writing dy by dx as y1, 1 plus x square into y1 is equal to 2 times tan inverse of x. That is a differentiating. Again, we have to take second derivative because they have asked second derivative here. We will take second derivative once again. Therefore, 1 plus x square into y2 is equal to 2 times, that is 1 plus x square into y2, that is product rule. 1 plus x square into y2 plus y1 into d by dx of 1 plus x square is 2x. That is equal to 2 times dy by dx of tan inverse of x is 1 over x, 1 plus x square. Therefore, simplifying, we get 1 plus x square into y2 plus 2x into multiplying 2x into 1 plus x square equals 2. That is cross multiplying with 1 plus x square. So 1 plus x square becomes 1 plus x square whole square here. You see here 1 plus x square whole square is here. That is the answer. For that you will get 5 marks. 43. The length of a rectangle is decreasing at the rate of 3 centimeters per minute and width is increasing at the rate of 2 centimeters per minute. When x is equal to 10 centimeter and y is equal to 6 centimeters, find the rate of change of one perimeter and the rate of change of area of triangle. That means here the length is decreasing and width is increasing. So we have to find the rate of change of perimeter and the area of the rectangle. Since length x is decreasing and width is increasing with respect to time, we have dx by dt equals minus 3 centimeters. It is decreasing, and dy by dt is equal to plus 2 centimeters per. That is the width is increasing, the length is decreasing. So therefore, the perimeter is given by P is equal to 2 into x plus y. That is, the rectangle is 2 into x plus y. Therefore, dp by dx is equal to 2 times dx by dt plus dy by dt. That is equal to, given dx by dt is 3 minus 3 and dy by dx is plus 2. Therefore, dp by dt is equal to minus 2 centimeter per minute. Therefore, now so the perimeter is decreasing 2 centimeters per minute. Now we will find out the area of the rectangle is given by length into breadth, that is x into y. A is equal to x into y. Therefore, dA by dt is equal to dx by dt into y plus x into dy by dt. That is the product rule. Therefore, dx by dt is minus 3 into 6 plus x is 10 into dy by dt is 2. Therefore, simplifying, we get 2 centimeters per minute is the answer. Very simple problem. Next question. Find the integral of 1 over a square minus x square with respect to x and hence evaluate 9 minus 25 square. This is a standard derivation. It has been worked out. It has been worked out as integral. In the, you please go through the chapter number 7 and these are given. Okay, and you find out the values as explained. So only finally in the given equation we have to find, here put the values of a as 9, a square as 9 and b square as 25x, and you will get dt by 3 square minus t square. So it is sine inverse of t by 3. This is also a worked example. You please go through it. Next question. So this 39, question number 39 was left out due to lack of space. Now it is, we will solve it here. Check the injectivity and surjectivity of function f such that r belonging to R defined by fx is equal to 3 minus 4x. Is it a bijective function? This is also a worked example. We have done it in the chapter number 1. Okay. Given f belongs to R, belonging to R, f such that, given f such that R belonging to R defined by fx is equal to 3 minus 4x. Therefore, for any two elements x1, x2 belonging to R such that fx is equal to f of x2, we have 3 minus 4x1 is equal to 3 minus 4x2. If you put, therefore 4x1 is equal to 4x2. Therefore, x1 is equal to x2. Therefore, f is 1 on 1, 1, 1. Therefore, fx is equal to 3 minus 4x, or y is equal to 3 minus 4x. Therefore, x is equal to y minus 3 by 4. That is equal to 3 minus y by 4. That is belonging to R. Therefore, f of x is equal to 3 minus 4 into 3 minus y by 4. That is equal to y. That is substituting in 3 minus 4x. 4x we are substituting as 3 minus y by 4 equal to y. That is, f is on 2. Therefore, f is both 1 on 1, 1 dash 1 and on 2. That is, f is objective. Bijective, sorry, f is bijective. Now we will take up the next question. Question number 45. Using method of integration, find the area enclosed by the circle x square plus y square is equal to a square. So this is also a worked example in the respective section. and you can do it here. Application of integrals. Consider the strip shown in the figure. You please see the figure here. This x-axis is, this is x dash x, it is a, and this is a y-axis. Here the quadrant, let us consider a quadrant and a strip dy. dy, so in the area of circle is given as x square plus y square is equal to a square, where a is the radius, that is OA is equal to a. That means here a comma 0, that is x coordinate is a and y coordinate is 0. At the point B, the x coordinate is 0, x coordinate 0 here, and y coordinate is a, where a is the area of the circle. This is radius of the circle. Now if you consider a strip moving from y is equal to 0 to y is equal to a, we can and multiply this quadrant area 4 times, we will get the total area. So is the question we will read again. Using the method of integration, find the area enclosed by circle x square plus y square is equal to a square. So therefore we know this is 0 to a into x into dy. X is varying, x into dy. Therefore 4 times the quadrant, therefore it is 4 into integral 0 to a square minus y square. See here, if you simplify, x square is equal to a square minus y square. Therefore x is equal to a square minus y square under root. Therefore, we substitute the value of x from the equation of circle, that is equal to a square minus y square into dy. Therefore, it becomes, now it is a standard form of integration, and that form is integral square root of a square minus x square into dx is equal to x by 2 into square root of a square minus x square plus a square by 2 into sine inverse of x. This you have to remember. That is why I have given it in red ink, so that you can easily recall. Therefore, substituting the lower limit as 0 and upper limit as a. First we will put upper limit as a. Therefore, y is equal to a is a by 2 into a square minus a square is 0. So, the first term with upper limit becomes 0. And the second term is a square by 2 as it is sine inverse of y, a by a. Y is a by a is a, 1 by 1 is sine inverse of 1. Sine inverse of 1 is pi by 2. And if you put the lower limit, if you put y as 0, this becomes 0. And here also if you put y as 0, it becomes sine 0. Sine 0 is 0. So therefore the lower limit is 0. Only term remaining is a square by 2 into sine inverse of 1, that is equal to 4 into a square by 2 into pi by 2, that is sine 90 is 1. Therefore 4 gets cancelled. Answer is a pi a square. That is area of the circle is pi a square, where a is the radius. This is the answer. For this you will get 5 marks. Next question. Find the integral of solution of differential equation x into dy by dx plus 2y is equal to x square. So we have to find the general solution for the differential equation. So the given differential equation is x into dy by dx plus 2y is equal to x square. So we have to divide both sides by x. So if we divide by x, we will get dy by dx plus 2 by x into y, and x square by x is x. Therefore, it is of the form dy by dx plus py equals q. And integral function is given by e to the power of p dx, where p is 2 by x and q is x. So in the differential equations also, you please go through the chapter. The link is given in the description part, and this standard form of integration is also done. We have done a number of problems on this. Therefore, integral p dx is equal to integral 2 by x into dx, that is equal to 2 log x. Therefore, integral function is e to the power of p dx is equal to e to the power of 2 log x, that is e to the power of log x square, that is x square, because e to the power of log of fx is equal to fx itself. Therefore, the general solution is given by the formula y into if is equal to integral q into if dx plus c. Therefore, we will put these values. Y into x square, y into x square is equal to integral x into x square dx plus c, that is equal to integral x cube plus c. Therefore, y is equal to dividing by x square, we get this is x to the power of 4 by 4 into c of x to the power of minus 2. So this becomes x to the power of 4 by 4, and which is a general solution. Next question. Derive the equation of line in space passing through the given point parallel to the given vector, both in vector and Cartesian form. This is also a standard derivation. Please go through in the textbook, and we have also worked out in the our videos. Okay, then you copy down and repeat it. This I will skip. You read it again. I have given in the respective derivation. This is a standard derivation. Next question. Probability of solving specific problem independently A and B are 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is exactly one of them. Solve the problem. Let E equals A solves the problem. Let F be B solves the problem. Therefore, probability of event E is equal to half, and probability of event F is 1 by 3. Therefore, first option, that is the problem is solved. P, the problem is solved. Let P of problem be solved is P of at least one of them solves the problem. Therefore, that is 1 minus probability that neither A nor B solves. Therefore, 1 of minus of P of E dash intersection F dash, that is equal to 1 minus P of E dash and F dash, that is equal to 1 minus probability of E dash into probability of F dash. Because E and F are independent, therefore E dash and F dash are also independent. Therefore, that is 1 minus probability of E into 1 minus probability of F. Therefore, that is 1 minus 1 half 1 minus 1 by 3, that is equal to 1 minus of half into 1 by 3, 2 by 3, that is equal to 1 minus 1 by 2 into 2 by 3, that is equal to 1 minus 1 by 3, that is equal to 2 by 3. Question number 2. Exactly one of them solves the problem. Therefore, probability A solves the problem but B does not solve. or B solves the problem A does not solve. That is, A solves means event E and B does not solve means F dash. Therefore, the first option is probability of E intersection F dash plus probability of F intersection E dash. That is, A does not solve the problem. Therefore, probability of E into probability of F plus probability of F into probability of E dash. Events are independent. Therefore, a probability of E is half into, this is 1 minus 1 by 3 plus 1 by 3 into 1 minus half. 1 minus half, that is equal to 1 by 3 plus 1 by 6 equals 3 by 6, that is equal to half. Part E. In this section, you are required to answer one question. In the examination paper, you will be given two questions. That is question number 49 and 50. Question number 49 will also have part A and part B. So part A will be of 6 marks and part B of 4 marks. Similarly, for the question number 50. So out of these two, you are required to answer one question of 10 marks total. Let us start. Question number 49. Prove that integral 0 to a of f of x dx is equal to integral 0 to a f of a minus x dx, and hence evaluate 0 to a of square root of x divided by square root of x plus square root of a minus x dx. This part is of 6 marks. This is also a standard property of the definite integrals. Consider integral 0 to a of f. Put a minus x is equal to t, and therefore minus dx is equal to dt. That is, differentiating, we get minus dx is equal to dt. When x is equal to 0, t is equal to a. And when x is equal to a, t equal to 0. This is the limits we have found. Therefore, integral 0 to a of f of a minus x dx becomes f of t of a to 0. Please note the reverse in the limits. The lower limit of the left term equation becomes upper limit of the right hand side terms. Therefore, f of t dt, that is f of t of minus dt. Therefore, that is equal to right hand side is integral 0 to a ft dt or integral 0 to a fx dx. Let I is equal to 0 to a of the given equation, that is, let I is equal to 0 to a of root x divided by root x plus root of a minus x dx. That is the given equation here. Let it be equation 1. Therefore, that can be written as integral 0 to a of, putting x as a minus x, f of a minus x, that is equal to square root of a minus x divided by a minus x plus a minus of a minus x. That because x is a minus x. Therefore, dx, that is equal to 0 to a of square root of a minus x divided by a minus x, a gets cancelled, square root of x. That is equal to equation 2. Therefore, adding 1 and 2, we have 2i, that is I plus I is equal to 2i is equal to 0 to a. This is equation 1 here and equation 2 here. So we have put it. Therefore, it becomes integral x plus the numerator x plus square root of x plus square root of a minus x divided by a minus x square root of x plus square root of a minus x is common in the denominator. That is, we taking LCM. Therefore, that becomes 2i is equal to 0 to a. This becomes 1. X plus this gets a numerator and denominator get cancelled and 1 of dx. Therefore, integral of dx is x. Therefore, upper limit is a and lower limit is 0. That becomes a. Therefore, I is equal to a by 2. That is the answer. We'll go to part B. Part B is find the value of k if f of x is equal to kx plus 1 for x less than pi, less than or equal to pi, and f of x is equal to cos x if x is greater than pi. These are the limits they have given, the values of x. Continuous at x is equal to pi. So we are required to find the value of k if fx equals kx plus 1 if x is less than or equal to pi and cos x is less than or equal to is continuous at x is equal to pi. Therefore, given fx is equal to, the given equation is copied as it is, and give this condition that x is continuous at x is equal to pi. Now we have to take left hand limit. Left hand limit of fx is equal to left hand limit of kx plus 1 because it is given. That is equal to k pi plus 1 because x is equal to pi. Therefore, now we will take right hand limit. Right hand limit is limit of f of x for x greater than pi is cos x. So we put the value of fx as cos x. That is equal to cos pi, that is equal to cos 180, that is cos 180 is minus 1. Therefore, put x is equal to pi in 1, f of pi is k pi plus 1. Hence, it is given that f of x is continuous at x is equal to pi and the left hand limit of f of x is equal to right hand limit of f of x is equal to f pi. Hence, putting k pi plus 1 is equal to minus 1 and k pi is equal to 2. That here, if you put k pi plus 1 is equal to minus 1, it 1 goes on the right hand side. K pi becomes equal to minus 2, and therefore k will be equal to minus 2 by pi. Question number 50. Maximize z is equal to 4x plus y subject to constraint x plus y is less than or equal to 50, 3x plus y less than or equal to 90, x greater than 0, y greater than 0. This is also this problem we have solved in the regular video. So let us write the constraint equations as given below. X plus y is equal to 50, 3x plus y is equal to 90 and x and y greater than 0. Hence we will write we will find the values of x and y. When x is 0, y is 50 and when y is 0, x is 50. Similarly, when x is 0, y is 90 and when y is 0, x is 30. So we will mark the equations and we'll draw the graph as it is. So this points A is point A 0, 50. This is 0, 50. And when y is 0, x is 50. So this is 50 here. So this is one straight line, that is x plus y is equal to 50 is a straight line. 3x plus y is 90 is this straight line. It is intersecting, and vertex B is 20, 30 from the graph. We can even solve the equation. When we write this, the point C is given as it C is given, C B A is given. So in this way, we will draw the graph and calculate the values, and note the values 0, A, B, C. So the point 0, 0 is noted. X is 0, Y is 0, and A is 30. When X is 30, Y is 0. Therefore, this is A, point A, and point B is 20, 30. It is given here, and point C is 0, 50. For these vertexes, 3 A, B, C vertexes, the values of X and Y are given. For these values, we calculate the objective function z equals 4x plus y, which is given here, the objective function, and we have to calculate the maximum value. When we put z is equal to 4, z is equal to 4, I'm sorry, z is equal to x is equal to 0, y is 0, p is 0. Therefore, when x is 30 and y is 0, z is equal to 120, and when x is 20 and y is 30, z is equal to 110. And similarly, when x is 0 and y is 50, in this equation we get z is equal to 50. So from this equation we get maximum value as 120. So hence, from the above table, we observe that maximum value of z is 120 and corresponds to x is equal to 30 and y is equal to 0. See, y is 0 here and x is 30. You please draw the graph. You have to select proper scale on x-axis and y-axis as shown in the diagram and practice it. Finally, we will come to part B. If A is 3, 1 and minus 1, 2 satisfy the equation A square minus 5A plus 7I equals 0, then find the inverse of A using this equation where I is the identity matrix of the order 2. So you please note here we have to find the inverse using this equation. Let us do it. Answer. Given A is equal to 3, 1 minus 1, 2, which satisfies the equation A square minus 5A plus 7, 1. Here you are not required to prove the equation. It is already given the condition, it satisfied. Hence, we have to start from this equation. So to find A inverse of A, multiply both sides by A to the power of minus 1. Therefore, A square into A to the power minus 1 minus 5A into A to the power of minus 1 plus 7I into A to the power of minus 1 into 0 into A to the power of minus 1. Therefore, A square into A to the power of minus 1 is A, and 5 times I2 plus 7 into A to the power of minus 1. That is equal to 7A to the power of minus 1 equals minus A plus 5 times I2. Therefore, 7A to the power of minus 1 is equal to minus A. Minus A is 3, 1, minus 1, 2 plus 5 I. I2 is 1, 0, 0, 1. That is equal to 7A to the power of minus 1 minus 3, 1, 1 minus 2 plus 5, 0, 0, 5. Therefore, 7A to the power minus 1 is, we add this, minus 3 plus 5, minus 1 plus 0, 1 plus 0, minus 2 plus 5. Therefore, A to the power of minus 1 is equal to 1 by 7 into 2 minus 1, 1, 3. So that gets, so that is the inverse, this is the inverse. Please note that we are required to find A to the power minus 1 from the given equation. We should not use a to the power of minus 1 equals adjoint of a divided by mod of a. This formula we apply for some other case, but not for this case. With this, we come to the end of this paper number